And we're back. So, we got segment 4. We got some learning objectives here. So, some of the things you should be able to accomplish by the end of this activity, you're going to be able to explain the difference between divergent, convergent, and transform boundaries.
Yeah, they did divergent in the last one, and and convergent too.
Yep, and we're going to get to transform in this one. Then you're going to be able to list examples of each of those 3 types.
Okay.
And then you're going to be able to analyze earthquake data to determine those relationships between earthquake depth and the type of plate boundary.
So really, they're tying the stuff they did in the last one, learning a little bit about transform boundaries and earthquakes. So just a little bit of new stuff added to what they already know.
Absolutely. Then you're going to be able to analyze patterns or occurrences of earthquakes in relation to tectonic plate boundaries. Okay, you're going to be seeing how earthquakes basically relate to those plate boundaries. You guys ready to do this? Good, we are.
All right, seismic activity in the Pacific. The Pacific Ocean, that's that big one, right?
Absolutely, yeah.
Okay, and the white stuff, that's from Google Earth. That's showing some, is this seismic? Yeah, seismic activity.
So yeah, actually, guys, what you guys are going to want to write down is you're going to want to look at your key right on the bottom here. So if you take a look, the white patches or the white dots are earthquakes that are really shallow depth. So that's actually a depth of 0, right at the surface. Okay, so you can see a lot of really shallow earthquakes kind of across that divergent boundary we saw in the middle of the Pacific. You see some at the divergent boundary right across the Atlantic as well. And these are all really shallow earthquakes. They're found right at the surface.
These are the ones Mr. Z and I were talking about, I think, because the lava's moving up and it's forcing the Earth to open up.
Absolutely. Okay. Next thing you're going to want to write down is you're going to want to look at the deeper ones. The darker red and the little pink ones, those ones are much deeper. They're actually about 300 kilometers down. Okay. And the places we find some really deep ones is as you get into South America here. You can see you start from the surface, and as you move, as you move towards the interior of South America, so towards the east, they actually get deeper and deeper as you go.
That was like when they did their homework or their menu, or not their menu, their mastery check. They might have picked that as their divergent or convergent, where one plate's diving under the other.
Yeah, so as they're diving down underneath the other one, you can actually see that you're going to have deeper and deeper earthquake depth as you get across.
So as the plate's pushing, that's the dense one, right?
This is the more dense one subducting underneath the less dense.
So it's pushing on the other rocks there, and as it grinds and it gets caught, that part right there, deep earthquakes?
Absolutely.
I think we got this.
Perfect. So make sure you guys write that one down. When you see deeper earthquakes, or that are increasing in depth as you go, you're looking at a convergent boundary.
This one, let's see, volcanic activity in the Pacific. Still in the Pacific, but let's look at our menu. Now we're looking at volcanoes.
Absolutely. So you're going to want to write down that you're looking at volcanoes.
It's not the same exact pattern, is it?
Okay, it's a little bit different. So remember, before we had a whole lot of volcanoes right through the Atlantic. We had a whole lot of earthquakes through the Atlantic and a whole lot of earthquakes through the Pacific. Mm-hmm. It's not the case anymore. Now we've got a whole lot of volcanoes that are right along the western coast of South America. And they go all the way up, right on through North America as well.
That kind of matches where they had the deeper earthquakes, doesn't it?
Absolutely does. We're seeing much deeper earthquakes in the same spots. We're seeing a lot more volcanoes.
Connections. You gotta write this down, that there are some connections between deep focus earthquakes and the volcanic activity.
And those ones were found near what type of plate boundary, Mr. Bill?
They're coming together. It's a C word. Converge?
Convergence, absolutely. So as they're subducting, you're actually melting the more dense plate, and as you melt it, it starts to rise back up. So and as it rises, you start getting your volcanoes that form at the surface.
So that was your oceanic plate going down, more dense. And when it goes down here and it gets in the earth, it gets hot, earthquakes happen, and then when it gets hot enough, no more earthquakes, but then lava comes up and makes the volcanoes there.
Absolutely. I think we look at a picture in this in a little bit, probably in the next slide.
Then coming right up.
Nope, I made that up. Good.
Oh, it's coming up. Transform boundaries. Let's see if there's a connection here. Same side of the western coast of the United States. That's where we saw volcanic activity, right? Mm-hmm. And we saw some earthquake activity as well. We can't see South America here, but I see these lines. What could these lines represent?
So these lines are the different types of plate boundaries we have here. So right across California, we're starting to see some blue lines. Then we start to see some green.
So up there in the upper right-hand corner, that's that transform. So the blue is a transform boundary.
Yeah,
the new
so
one.
something you're going to want to write down
That
is
they-
where you see the blue lines, you see transform boundaries. So right across through like the northern tip of Baja California, right across San Francisco, Los Angeles, all that's going to be a transform boundary. If you took a look, before we started moving plates towards each other, started moving them away from each other, now it's going to be like they're moving side by side. So it's like if Mr. Bin and I were walking past each other, we would just kind of brush up against each other.
Boy, that could cause an earthquake.
Yeah, I'm on a different side. This is all kinds of different over here. Let's
Yeah,
transform back. Transform boundary.
Oh, much better.
Okay? So, do you guys think this will be a really deep or a really shallow earthquake?
Well, we didn't go down and we didn't go up, so we kind of stayed right on the surface, right?
Right at the surface. So, when you see transform plate boundaries, look at your earthquake depth. Okay? We saw that the white earthquakes, if we look at our scale down here, our key, the white earthquakes were really shallow. They're found right at the surface. So another place you see shallow earthquakes are where you see these transform boundaries.
Hey, my family just went to California, and we were a little worried about earthquakes. One happened, it was really, surface, and it was small, wasn't a big deal. But I remember, don't they have like a big fault like running through like San Francisco area?
So the famous one you're thinking about is the San Andreas Fault.
Oh, okay.
Okay, and actually what's happening is the plate that's on the Pacific Ocean, the Pacific Plate, is moving to the north and the west, and then the plate the North American plate is moving south and to the east.
Now, that's a type of transform boundary, isn't it?
Absolutely, because they're sliding past each other.
Now, given enough time, could part of California actually move away from the rest of it?
Absolutely.
No way.
A lot of people say, and the evidence supports, that if it keeps moving in this manner, you're actually going to lose part of California and Baja California, and you'll get an island right across here.
We can't see it in the screen, but I wonder if it could ever get to Alaska.
I bet if you gave it enough time, you might be able to get up there.
That's pretty interesting.
Okay, well, let's start moving to the next one.
They're going to have to take notes on this one, too?
They should probably start writing some more stuff down.
There's a lot of stuff on here. Let's see. Transform plate boundary and seismic activity. I think we've already talked about this, so this should be a pretty good review.
Should be a breeze.
We said transform fault boundaries. You said that's going to be like the San Andreas Fault.
Yeah.
So we're looking at some faults, some cracks here.
And if you look at both these pictures, we've got the fault line that's running right across the coast. Same here, where we got the fault line that's running right across the coast, right up through Sacramento and San Francisco and San Jose. If you look at the the key right on the side, you've got earthquakes in the last hour, the last day, and the last week. And the bigger the earthquakes, the bigger the square you have. So you see a lot of earthquakes that actually happen within the last week. You got a couple within the last hour that happening right across California because of those plates sliding past each other.
So these aren't all huge earthquakes, but these are actually earthquakes that happen all the time because these plates are moving all the time?
Absolutely, they're always moving. And if you guys want up-to-date information, if you click on this website, you can actually go and see live earthquakes. You can see up-to-the-hour earthquakes data from the USGS and from some other group. ANSS, sorry. So you should be able to see current earthquakes that are happening. You guys might want to take a quick second, try and find some of these new earthquakes. We'll give you guys a second. You can pause the video. We'll give you time to check those out. All right, and we're back.
Ooh, that's a new color picture.
Absolutely. So what we're setting you guys up for here is a quick video that's going to show you a little bit of how those transform faults and the boundaries work. So what I want you guys to do, pause this video, pause our video, and you're going to go up to the top of the slide deck, and you're going to play the video.
Now, during the video, do they still have to take notes?
Absolutely. Take notes on this new video.
We're going to ask some questions about it, aren't we?
Absolutely. So you guys pause this one, go up, watch the other video. We'll be right back waiting for you. All right, Mr. Bin, that was really interesting. What'd you think?
I was pretty amazed. I could make some real connections there between those boundaries.
Absolutely. So next thing we're going to do is we're going to start talking about some more of the volcanic activity we see along the Pacific coast, all the way around it. So there's a whole lot of volcanic activity around the Pacific coast, what I want you guys to do is you're going to watch this video, and you're going to see a great video, and you guys want to start writing some of this stuff down. So
No
we're not going
way.
to talk much about it. You guys are going to be able to write this down, and we're going to talk in class about what you guys saw here. So you guys can pause the video, go on up to the top of the slide deck. You're going to come back, visit us in a sec.
This would be a great time for a switch.
You know what, Mr. Ben? My hand is really hurting. You take that over.
All right, I don't
Mr.
think I can.
Baldwin, I'm going to invite Mr. Z in here to talk to me.
Whatever.
Mr. Z,
See you guys
Coming
later.
back.
Hey,
Coming
come
back.
on. This
I
is
didn't
our
wanna be in
favorite
your
subject.
video anyway.
It is our favorite
Well,
subject.
you're not going to talk about the Hawaiian Islands with us. We're like the hotspot king and queen here, so I'm not sure what that one
Yeah.
means.
Yeah. All right, so Mr. Watt and myself, Mr. Z, are back with you again for mantle plume volcanism and the Hawaiian Islands. You know what, Mr. Watt? What kind of plate boundary is by the Hawaiian Islands?
You know what, Mr. Z? The Hawaiian Islands are sitting in the middle of the Pacific
The
Ocean.
middle.
There are
Huh.
volcanoes there. We know that because they're still erupting today.
They are. They
But-
are still erupting, and they have been for quite a while, like
There are-
30 years,
Yeah,
huh?
no plate boundaries within thousands of
Huh.
miles.
Because I know that there's volcanoes at convergent plate boundaries.
Right.
And I know that there is some volcanism at divergent plate boundaries too.
Yep. But no volcanism at transform plate boundaries.
No.
But this isn't a transform plate boundary.
It's not a transform either.
And it's not convergent, it's not divergent. So
Huh.
there's something else happening in the Hawaiian Islands. And I'm really glad that we're talking about this briefly now because I know the students are going to spend a whole day investigating what's really happening with the formation of the Hawaiian Islands
Yeah.
and looking all the way back, all the way to the Aleutians.
Yeah,
So
and
that
we're
should
going to
be
be
some pretty good information. Thanks, Mr. Ben. So what we want you to do here with this one, oh, can we pop back to that slide just a second?
Yep.
What we want you to do here with this one is we want you to hop out and we want you to go to this particular little animation. And what you're going to see here is you're going to see an animation that shows how the Hawaiian Islands are actually forming. So we want you to think about hot spots and about where the magma is generated from and the fact that this little blue slice on top of it, that's indicating that oceanic plate, the Pacific Oceanic plate, as it's moving over the hot spot. So it's not a video, but in this one you hop out to the animation itself and then click through the animation. While you're doing that, you'll want to take a couple of notes on
Definitely.
what's happening to form those Hawaiian
You
Islands.
definitely want to write some of that stuff down.
Great.
All right.
So go ahead and hop out. We'll join you in a few minutes. All right, well, I think this is going to kind of help us wrap this whole chapter up, and it's been kind of an intense chapter
It
talking
is.
about seafloor spreading, divergent plate boundaries, convergent plate boundaries, transform boundaries, and now hotspots, and we've talked about the topographic profiles of the different oceans and why there are earthquakes in certain places and volcanoes in other places, but we're still going back here to Wegener's whole problem, and Wegener's
Yeah.
problem was...
He did not have a mechanism, and he didn't know what was causing these plates to move, and that's what we're going to tackle in this slide. So this is hopefully going to just tie all of that together, all right, for us. So let's take a look at some of these pictures.
You know, one of the really interesting things, because I'm kind of a hard rock person, and my training was in igneous and metamorphic petrology, and I know that I had grad students who were in school with me who were actually working on this, and they were doing PhD dissertations and arguing
Wow.
one side or the other. But do you know that geologists still really don't agree on whether it's being pulled or pushed
Yeah,
that's
I've
causing
heard
all
that
this plate
before.
motion?
Yeah,
So we know a little bit more about the mechanism,
Mhm.
but we still don't have it completely tied down as
Got
to
it.
really what's going on.
okay.
But let's talk just a little bit about the two main ideas,
All
the
right.
ridge push and the slab pull.
Okay. All right, so let's take a look at these pictures over here. So, what we want you to do is make a concept map explaining the possible driving factors behind these, and we're going to talk about that here. So, way up there at the top, we've got our plate motion, and then we have our two driving mechanisms illustrated here. We have on the left is ridge push, and then on the right we have our slab pull mechanism.
Okay,
All right.
so those are a little bit different. With the idea of ridge push, remember this is at a divergent plate boundary where the hot magma is coming up and it is pushing the plates apart. So the idea is that all of plate tectonics then would be driven by that hot magma pushing plates apart.
Okay.
And that's different from slab pull. What happens with slab pull?
Well, slab pull at a convergent plate boundary where we have one plate subducting under another, an oceanic plate subducting underneath a continental plate, that plate is being pulled into the Earth. And the thought is that that's the driving force that's causing the plate motion.
So it's the mass of this plate that's going
Exactly.
down into the upper mantle that's actually pulling the whole plate behind it along.
That's right.
Okay. Well, those are two different ideas, and what we want you guys to do here is we want you to kind of explain ridge push here in your concept map, and you can do it right on your notes page, and slab pull, and get some differences between those two ideas.
Definitely.
All right, for your concept map? And then let's go on to the next slide. So here we've got the last mastery check of this, and I think this is a really good one that will help the students tie together everything that they've learned from this
Yeah,
chapter.
this one's a lot of fun.
Yeah.
This one asks you to write a script for a news report on a California earthquake based on what you've learned in the segment. The script is for a TV channel in Hawaii, so you will need to make sure to explain why there are no similar earthquakes in Hawaii. Let's take a look at that question. So California, what do you think they might be thinking about if they're thinking about California in terms of plate boundaries?
Well, I think California was a transformed plate boundary,
it was, right?
Which
And
caused
remember,
those shallow earthquakes.
Yeah, and
Yeah.
those are the plates moving side by side from each
Right.
other. So they're not moving towards or away; they're moving side by side. And there's some characteristics of that plate boundary. You may want to go back into your notes and find that.
But the people watching this news report in Hawaii are going to be used to hearing about earthquakes associated with volcanic activity in the
Exactly.
Hawaiian Islands, which isn't caused by a plate boundary. So that's what they're going to want to take
Yeah.
advantage of here as they're writing their script.
Yeah, definitely.
Now you want to make sure that you include at least 2 diagrams in your explanation, and you can grab those diagrams offline and then post up your script on your Unit 2 page. Sound good?
That sounds great.
All right, great. Can't wait to see what you guys come up with. Want to hear your news stories. Thanks, Mr. Z.
All right, thank you, Miss Owen.
All right.
All right, see you
Bye,
next
guys.
time.